21. Now we're going to linear equations. Okay, so equations. So equation, what does that mean? That means there's an equal sign. Makes equation. Now, for example, we talked about before so-called a polynomial expression or algebraic expression. So in this case, expression, for example, it is like 3x plus 7. All right. Now, in this case, x can be any value. So the 3x plus 7 has infinite number of values, depends on how much you let x be. X can be 1, x can be 2.4, x can be negative 3 over 4, you name it, right? So then depends on how much x is. So x, if x has a value, then 3x plus 7 has another value. Now, for example, x equals to 1, and then this equals to 10, if my calculation is not wrong. Okay, now it say, okay, well, then x is negative 1. Okay, x is negative 1, and negative 1, so this is a 4. 3x plus 7 is 4. So this list can go on forever. However, if now I say 3x plus 7 equals to negative 9, then here x can be only one value now, because this x now, the value is controlled by this equal sign, and also controlled by equals how much it equals. So there's only one value for x. So now our job now is just to search, is to so-called solve for x. Solve for x. So find out if there's an equation like this, then how much x has to be in order to satisfy this equal sign. So we call this solve for x, or find out the x value. Now, what does a linear equation mean? Linear means x, the power is 1. Now go back to review what is a polynomial. We said polynomial, or the term, one term of a polynomial, that's a product of a number. Product of a number with a variable, and also the variable also has a power, right? The power of anything. Okay. Now linear means a equals to 1. All right. So now, for example, we started from this very straightforward finding x example. Now in this way, I can also say I have a number. My number plus 2 now give me 5. Find my number, right? So I have a number, or I have a number, use n, doesn't really matter, and plus 2, then that give me a 5. Now find my number. Now in this case, okay, well, from the 5, I'm going to subtract 2, and then I should go back to my number. So my number is 3. Now, so in this case, we're doing the reverse thing. So I get a 5 and subtract 2, I get my original number. Another way to do this, more so called algebraic way, saying is that on both sides of the equation, if we do exactly the same thing, then the equation still equals. So in this case, I can subtract 2. Subtract 2. Why do I want to subtract 2? Is because I want, in the very end, is only x remains on one side. So this cancels. Then 5 subtract 2, then that is 3. So this is also another word, mathematically, it's called isolate. Isolate the x, right? By this kind of procedural thing. Okay, so now here we go. Now this is the 2x subtract 3 and x plus 5. So in this case, we needed to move the x to one side. So then x can be collected with x. So we so-called collect the like terms. So in this word, we minus x on this side, so it's minus x on this side. So this x, in other words, move to the other side. When the x move to the other side, the positive become a negative, negative become positive. And then we're going to move the 3 to the other side. That becomes a positive 3. In other words, is plus 3. Now plus 3. All right, so then the 3 is gone. So let me just rewrite this. So 2x subtract 3 equals to x plus 5. Now in this case, I'm going to move the x by subtracting x. Sorry, this should not be, I don't need this equal sign here. Sorry, guys. So let's get rid of this equal sign. Okay. So subtract x on this side, then I have to subtract the x on the other side as well. So now in this case, this x is gone. So then I have 2x subtract x, subtract 3 equals to 5. Right? Now here, this one becomes a collect the like term, or put the x together, that becomes x. Now here, I want to move this negative 3 to the other side. That becomes a positive 3. Why? Because I'm going to add 3 on this side. I'm going to add 3 on this side. So when this side, the 3 is gone, and showed up on the other side, and then it's a positive 3. Then that equals to 8. Now next example is like multiply. Well, multiply is the same thing. So I'm saying I have a number, multiply by 3, give me 15. Now what is my original number? Oh yeah, for sure, because my 15 divided by 3, that go back to my original number, right? But mathematically speaking, again, here, procedural speaking, we subtract, no, divided by 3 on both sides, divided by 3 on both sides. Well, then x is isolated, and x also being located. So then that is a 5. Now very similarly, now I got negative 2 over 3x equals 6. Now same thing. This is just the coefficient. We also talked about the coefficient. The coefficient now, it is just a fraction instead of a whole number. And also a negative number. So this one equals to 6. The coefficient for x now is this. Now I'm just going to divide the whole thing. This one means divide the negative 2 over 3. So then this one all gone. Now x now equals to, let's just do the division. And we did this in chapter 3 many, many times. And many, much more difficult examples than this. So then that means 6 multiplied by negative 3 over 2. Now again and again, cancel. This is 1, this is 3. Now x equals to negative 9. All right? By the way, when you write these solutions for solving for x, always go down this way. Okay? This means x equals to this, then change to x equals to that. Do not go the sideways. The sideways is looking like this. Oh, okay, well then now x just equals to negative 9. No, please do not do that. This means my equation was like this before. Now my equation changed to this equation. Then I found x value. All right. Now, the rest of it, this is the same thing as I just demonstrated above. You should be perfectly fine to do all the exercise. The algebra tile, we do not touch that. So that should be just perfectly fine. Okay? And there's application, there's word questions. We're going to combine the word questions in chapter 6 and treat it at a different section to study together. Very good. Thank you for watching.